I can go through the control of the shuttle control of that N-gauge thing that I've done.
Fire away, Ron.
Sorry, what did you say?
Fire away.
Okay, well, some people might have known, but I've got a little N-gauge shuttle a layout that I'm doing the control for. Now, if I share a screen, there it goes, share. Oops, where is it? Right, can we all see that?
Yep, that's fine.
Okay, well, that's the layout. There's basically 5 ends and a turntable. Turntable is causing a bit of a problem, but what I want to do is just sort of show how I've done the automation. It shuttles from end to end, and you can see the table underneath that actually sort of maps out all the possible routes. So what I do is I've got a start there and a finish. So when it finishes a route, I know where it is. And so what I do is I just generate a random route, another random route index. And I then look at that route to see where the start is and make sure that the start corresponds to the finish of where I am now. Now, if it doesn't, then I just go and generate another random route number. And I just keep on doing that until I actually find something that actually matches. And then once it matches, I've then got all the information I need to actually run it. So I can set the points according to this, to these ones, or binary, the same thing there. I can put the turntable in the right position by looking at this count. Sometimes I don't need the turntable, sometimes I do. Then there's the forward or reverse, and the TT relay, which is the I might be going forward on the main route, but I might have to go into reverse on the turntable. Depends on which orientation it is. So I've got a reversing relay for specifically for the turntable, and so really that's how I've actually put the information into a structure, into a C code, and then I can pick out all the information I need to actually run the next sequence. Although they're doing this random thing, picking up a random, and if it works, use it. If it doesn't, go to the next one. I think it's quite snazzy, but I stole the idea from a company I used to work for that did the gaming machines, or as some people call them, one-armed bandits. And that's how they do that. That's how they get around the law saying it's a random result, but it's random providing it conforms to what they want to do, which is give something like a 70% payback. So it's a bit of a fudge on that lot, and but it's quite a good way because to do it on this. I did initially try to actually work out the actual routes and sort of have one following the other. But I kept on getting into a situation where it couldn't get out of it. Whereas I found using the random, if there is a route that you can follow, it will eventually find it. So you don't have to worry about, sort of will this route follow the present one and what have you? Will it get stuck? It doesn't get stuck because the randomness will eventually go round and round a circle until it actually finds a route that's valid. That seemed to work quite well. I've actually sort of I demonstrated this before the lockdown, which had the A, B, C, and D routes working. I didn't have the turntable working. And I still don't have the turntable working because I'm finding positioning the loco on the turntable so that everything's on it, and which will allow me to turn it, is a bit difficult at the moment. I've got track end detection, and I use the same thing for the turntable, but it doesn't work because as soon as you hit the detector, it stops, and of course you've got half the loco sort of on the off the turntable, so it makes a bit of a mess when it starts moving. that's about it. The turntable, I just keep on going in one direction at the moment, and I actually have different counts for the different positions. And as I go round, I have one sensor on there that actually resets the counter. So I'm just counting the steps. It's stepper motor, and it's 24,000 steps per revolution. And as it goes round, it's incrementing all the time. And then as it goes past the sensor, it then resets it. So if it starts here, it'll keep on going up, and then it'll reset it, and then it'll gradually come back up to here. So it will always sort of find the right position, and it seems to work quite accurately. I'm quite pleased with it. It's when I try to go in the other direction that it's going to cause a few ructions, I think, but that's for the future. So that's about it. Any questions?
Ron, one thought for you on the position on the turntable. I had a similar problem where I wanted to clear a point. And what I would do in your situation is I have a sensor for position 1 and position 2, and I would stop the train once those positions are empty.
Yeah.
That depends on the sensor as well, because some of the sensors we have a delay to avoid the jitter. And it might make the train run off at the other end.
Yeah, I was thinking about that, but I was thinking if, depending on how you sense it, you can't really sense the end of the train, not by you know, the normal current flow, because some locos have sensors in the tender, and some don't. So that if they don't have sensors pickups in the tender, you're going to have the loco on the turntable, but the tender is going to be sticking out. Yeah, that's sort of came a cropper on that. And but so what I'm thinking of, particularly in this particular application, it's not a generic solution, but for this application, I'm thinking of putting a laser sensor across here. Now I might hopefully be able to use one laser for both positions. So as it comes on, it will cut the laser, and then I can then, you know, sort of say, right, it's on the turntable, I can now move on. But it's not a generic thing, so it's only this particular application that will work. You really need to have it working properly is to have a sensor, a point sensor on each end, but then you need to get the information back. You need to power the sensor, and you need to get the information back to the main controller. So yeah, that's something that is something I'm sort of thinking about, but not thinking about doing it yet. So I'll just I think I'm just going to put a laser across there and see if that works. So yes, it's fun and games. And then once that works, because I know what I've done the sequence, but by pushing the thing on before it actually moves, you've got to get there pretty quick, because you know, it sort of starts moving as soon as it thinks it's on there, it starts moving. I push it on there, and then it works okay. It goes backwards and forwards, and yeah. So but yeah, and I think this system, you can sort of add routes as and when, sort of, if I added a point here or something like that, or there's something else that stopped it, you can add routes as you add track, or you can add more different sensors. Say there's something that stopped it. So I had a level crossing here that was closed, and I couldn't get through. Then I could sort of include that in this table here. So yeah, it seems to work quite well at the moment, anyway.
Positioning the locomotive on the turntable, if you had a single sensor right in the middle of the turntable track, a reflective type sensor, and a reflective light target in the middle of the locomotive underneath, then you drive the locomotive on until you get an output from the sensor, and then the locomotive, when it's detected, is automatically in the centre of the turntable. So you don't have to worry about positioning it. If the sensor picks up the loco, you know the loco's in the centre.
Yeah, it would pick it up when the front went across. If the sensor was here in the center, it would pick it up as it crossed it, but then it wouldn't, the whole loco wouldn't be, it's an N gauge, so the loco wouldn't be completely on the turntable. You've got to have a sensor at the end, and so to make sure that the whole of the loco is actually on the turntable.
I didn't explain it too well. What I was thinking of is a sensor that operates by emitting a high power infrared beam upwards, which hits a simple reflective patch on the bottom of the locomotive, which is in the centre lengthwise of the locomotive, and then that's reflected back to an infrared sensor. And so you simply have one detector, and when it detects, the loco is automatically centered.
You could do the same thing with a magnet mounted under the center of the loco.
Yes, any sensor, providing it's designed to, it's in the middle of the section of track on the turntable, and whatever the target is on the locomotive is in the center of the length of the locomotive. Yeah,
that might work. The only, you've got to be careful that you've got to get the information off the from the turntable to the controller, and of course there's no set power. This is DC, it's not DCC, and there's no sort of constant power source there at the moment. It's running on slip rings, and I've got 2 slip rings, so I don't really want to have to add another slip ring.
Yes, I hadn't been considering that at all. It was just an idea for the single sensor in the centre.
But the idea of an optical sensor, you could actually. I'm just wondering if you could send. No, you can't really send a light beam up the middle. There might be something in that. Use light guides or something like that. Sort of.
Surely the simplest solution is 2 sensors, one at the start and one at the end of the track.
Yeah, well then that's what I was going to do. That would be a more generic solution, but it's a question of getting the information, powering it, and getting the information back.
But you don't need to. Why not just put the electronics in? Well, okay, it's N gauge, but I mean, where we looked at this in the past, you mounted the controls in the turntable itself, because you just need, you can turn the you have a DC feed, and then you can just use a relay to depower the track to stop the loco. So you could isolate the controls in the turntable rather than having to get them out through a slip ring.
Yeah, it could do. Yes. So if you had the
okay, your challenge with N gauge.
Yeah, well, the point is, I'm not a modeler. I'm into electronics, so I'm, as far as actually sort of having scenery there, I'm a bit of a heathen.
Well, then what I mean is that if you just feed in DC power at a particular, that's all you need, because you can control the turntable from the controller and stop the train.
Yeah. So that okay. That's an idea.
But surely the problem there is, how do you start it again afterwards? If you're using the 2 sensors to disable the track,
you could just reverse the polarity, and that could trigger the module to power up again.
Okay.
Yeah, I'll think about that.
Ron,
yeah.
Another possible solution might be to put sensors on the tracks leading onto the turntable, to determine that there is nothing on those tracks. Either light sensors or touch sensors, particularly if you had a high value resistor across the wheels of the tender of the loco. So there would be a small current passing. It would then register that there's nothing on that track, including the tender.
You're talking about the sort of current sensing or some sort, some
combination of current sensing totally on the tracks leading up, and possibly also light sensors at the very edge of those tracks, just to make sure that even the
nothing's there.
even the couplings are onto the space of the turntable itself.
Yeah.
I believe that the
Ron,
only
if
way
you've got
is
two
to read
sensors on the turntable, why don't you turn them on and off by using the turntable count, so that you would know from the count which one was at the right end, and you could turn the other one, turn that one off, and then you'd have the whole train coming to the other end of the turntable.
Yeah, well, I know which, you know, sort of, because I know the position of the turntable, I know what sensor I would need to, if the sensor was going back to the main controller, I'd know what sensor to look at. So I actually thought, it did cross my mind to actually use DCC. So you'd feed DCC into the turntable track. You'd have a decoder on the actual turntable, which then the output of the decoder would then drive the track. It's a bit of an overkill, I think, but it might work. But yeah, so there are various options that I'm looking at. So, but I'll get over the main problem with this laser thing going across and just get it up and running, and so I can show it. And then I can think later of a more generic solution. But yeah, because I think sort of this must be a general problem that everyone has try and use or put automation with a turntable. Any sort of automatic turntable will have this sort of problem. And so it'd be useful to have a generic solution rather than a specific one.
No shortage of comments from
No.
this group then, Ron?
No, hang on. What have I got? Yeah, it's quite a bit of a head scratcher there, but yeah, the main sort of shuttle part it seems to work quite well, and it never went off the end. So I don't have anything to stop it, but it always seems to have stopped. And what I've also done is with the end stuff. The end detection, I've actually, because it's diode isolated, the standard way of doing it with the diode, I've actually got, when it actually hits the diode or hits the area that's protected by the diode, I've actually got a large value capacitor across there, so that actually when it goes into that area, it actually charges the capacitor, and actually charging the capacitor passes current through the motor, so it actually sort of doesn't come to a dead stop, it sort of slows down. Problem is you need a fairly sizable capacitor to actually do that, but yeah, it works, and it works too well on. But the problem is, depending on the loco, you get the high efficiency locos you get nowadays, and it will run off the end, and it's virtually done that. It got about 2 wheels hanging off the end when I added the capacitor. So I've actually made a little extension bit for that, so for that part, but here it tends to stop dead. But yeah, it's all good fun, and it seems to work. I've got solenoid operated points; they're not servo operated solenoid. So yeah, and that's all written in C. I haven't done it in Arduino speak yet, but I might do that eventually. Once I get it right, I'll find writing in C is a much more flexible and much easier to do than Ardu speak. So yeah, or C++ as some people call it. Okay.
Ron, sorry.
Go on.
Ron, sorry. Does that run on an Arduino?
It runs on. No, not an Arduino. It's the same processor as an Arduino, but it is
much bigger.
Well, it's a home brewed.
Oh right.
Thing. I built it from scratch. It's not a printed circuit board. It's just wired underneath, and so yeah, and that's the turntable. You can see, as I said, I'm not a modeler. I'm a heathen as far as that's concerned. But yeah, you can see can you see the disc of copper? Well, that's printed circuit board, and you see the notch at the bottom there. well, there's two notches. The one is the effective one. So as it goes over, there's an actual sensor which you can't see because it's covered, but there's a sensor that gets uncovered, and then that resets the counter to 0 every time it goes around there. And all I do is I just do an equate with a counter that's actually incrementing with the count I want, and once it's equal, I stop it. The stepper motor is driven by the same electronics, and it's quite funny because not only I don't have acceleration or anything like that, I just go or stop, and also the timing, I'm not using a timer. I just use the loop time on the main processor. So it goes round, keeps on going round, and I think I go round 5 times per step. Hi, John. And yeah, and it seems there's no sort of strange noises coming from the step motor. I was quite surprised that I didn't actually have to have an accurate time on it. So it's just driven by the loop time, or 5 times the loop time per step, and I've got it at a rate that's reasonably fast, or reasonable speed, but it doesn't need acceleration, and so it just stops and starts. It's quite works quite well.
So Ron, when you were talking about adding, it's Dave Mason here, when you were talking about adding more sensors to the turntable, the moving bit, you said about the limitation of slip rings. Once you've got some intelligence controlling this system, can you not move away from slip rings and just have a loose cable loom going up to the moving disc, and make sure you don't go round more than a full turn and start twisting it up too much?
I could do. Well, yes, I hadn't thought of along those lines. Yes, because then I can have whatever I like. But I like the idea of Sod's law will say that I will wind it up and it'll go ping. I know it'll happen. But yeah, that is an option. I think it would be an option towards the end of my desperation level, but it is an option we could use.
You could put a header on the end so that when it winds it up, it just disconnects and then everything stops.
Yeah, yeah.
There are some nice 4-way slip rings on AliExpress that are very cheap. They're from the model, I think, model helicopter or somewhere. I can't remember what they're used in, but they're a couple of quid, I think.
Yeah. Well, I made these ones. These are it's sort of a piece of printed circuit board. In fact, the board that printed circuit board that you could see with the notch in it for the sensor on the underside. Yeah, I think you can just about, so you can't see the slip rings, but you can. I actually, where are we? I don't know if you can see. No, maybe you can't. Hang on, it gets a bit cumbersome. I don't know if you can see that disc there with the ring, with the slots cut out. Well, yeah. You know, the circular. It's basically I did. I cut it. I built it on the lathe actually, and I just cut a track bits of the copper out on the lathe, which actually gave me the slip rings. So I used a bit of phosphor bronze as pickups. So yeah, yeah, these are all good options and things to try. But I'll get it running first, and with the laser, and then we can.
The project I've just started on is an automated turntable for a hidden tiding. So I'm doing a whole train turntable. Anybody hearing me? Am I coming through?
Yeah.
I've hit all these problems. The solution I've come up with, I've got a pair of old, I don't know if anybody can see it if I hold it up. They're actually servo-driven blocks with the positioning table from an electron microscope, a BR, which came out of use. And I'm using these. And then I've got, I'm not quite sure whether it could be backlash free. I can't measure any backlash on it. So I think on a biggish turntable it might not work. So I'm going to have a deadbolt at the end of the table, and that's going to drive a crank which will push a buffer stop up into the track. So I'm worried about a train. This is a whole train which might have no loco coming off the end while it's turning. So I'm going to have sort of lifting dead stops at each end.
Hmm.
And then I've got enough space to have a sort of a ribbon cable wrapped round the pivot. Because I've got 2 tracks on the table and the sensors on the table. So I'm going to have several circuits. I'm going to need about half a dozen or more circuits. I'm going to have a ribbon cable which will just wrap round the spiral, round the centre pivot. I'll just have to remember that it only runs, since it only has to go just over half a turn, I'm going to put a couple of stops on it so the turntable will not be able to go 360 degrees, which will stop the cable ever winding up.
Hmm.
Once it gets to one end, it's got their stop, but it has to come back the other way.
It's very commonly used in process automation where you have cable snakes and the process automation ensures that whatever device is turning doesn't keep going in one direction, that it always comes back to release the cable snake. Yeah.
But I'm going to sort of doubly protect against it by just simply have a limit stop which will stop the turntable at each end. And of course, I can then, once I know where it is roughly, I can drive it up to that stop. I'll know exactly the position of it to reset the counter to position it back for the next turn.
I'm working on something similar, Roger, which would be a turntable traverser for whole trains. And because it's mounted against a wall, the traverser will move the turntable out from the wall in order for it to rotate and then move back in again. But the turntable mechanism is based on a large lazy Susan ring, so that the train is supported on a wider diameter, so it's got a completely hollow center. And I'm using this, which is a 6-wire slip ring, to communicate with it, which 6 wires gives me 2 wires for the DCC signal and 4 wires for C-bus, which means I can have as many C-bus modules mounted on this thing as possible, including servos to operate end arms that would come down and lock the ends to stop trains falling off, and position detectors, so it would have totties to determine that there's something on the track, and then hectors or something to determine specifically so that everything stops on a point exactly right before it reaches the end stop, and make sure that the trains are properly centered, and other sensors to see if there's something hanging off the end to stop it, as a fail-safe to stop it trying to turn. So because C-bus can be present on this thing with 6 wires, you can have as many gadgets and gizmos mounted on it as you like, sensors and things that happen to control it.
That a double O gauge project, Andrew?
Yeah, that's double O gauge, Dave.
I'd be interested in it when you write that up, because I always thought for a club it'd be very handy to have some form of reversing fiddle yard that could be bolted onto the back of layouts for exhibition use, so that the trains could run, turn, and come back. Yeah.
I'm making it as a 5-foot long version, so long enough to handle a 4-coach train, so sort of major branch line, but not an 8-coach express, main line type train. But I think 4 coaches is long enough for most purposes.
I always thought some kind of reversing elevator would be a great project.
Yeah, similar to that.
That'd be interesting.
But because it operates as a traverser, it also means that you don't have to have a fan of points leading up to it.
Yeah.
So that the length either side of this is greatly reduced. The whole thing just lines itself up with whatever tracks are going in, and then when it wants to turn, it slides all the way out and pivots over.
Fantastic. Be interested to see that written up somewhere.
Yeah. So the main bodywork of the thing will be laser cut using CNC sliders to operate. So it'll be computer controlled.
How many tracks on the unit?
I'm working on 8.
Right, so it's reasonably big. So
yeah. Yeah, well, it has to be quite wide because the center, when it extends out, the center still has to be within the frame, for the length of the sliders. It has to be within the length of the slider frame. So, that means 2'6" wide. Right. Moves it out, and the center it's then got a length wide enough for a 5-foot turn.
It's essentially a circle rotating in a rectangle.
Yes, exactly.
Mm.
So Andrew, that slip ring is very neat, very tiny. Yeah. I would be, I'm not a DCC user, but I would be concerned about a bit of crosstalk between the DCC and the CBus signals.
Well, I mean, I don't know. I mean, I'll find out when I find out.
It's very unlikely, certainly based on our experience. You can be very casual with the two wires there. You really want a lot of loco, drawing a lot of power at once to see any real problem. We had only one instance of crosstalk, and that's where the CBus wires ran for maybe 2 to 3 meters by mistake with the DCC power cable.
Yeah, I mean, if you look at the size of the thing, it is so small that with the 6 wires going in and 6 wires going out, that the actual area within which the wires are in any proximity to each other is tiny.
Yeah.
So I think the chance of anything happening is very small. But it's just a lovely little thing. It's a couple of pounds on eBay.
You can also fix the if you do get crosstalk, just put a couple of snubbers on we've just fitted snubbers to the DCC, and that fixed it, you know.
Andrew, could you help us out and post the eBay link for us on the forum, maybe?
Yeah, sure. I'll try. I'll see if I can find it and post up the link.
That'd be good.